So we're going to talk about finding inverse functions. The first thing, I think you might have done inverse functions in the past, so I'm hoping this is review. If it's not, that's fine. You should hopefully catch up quickly. So first of all, we denote an inverse function by that symbol. It looks like f to the -1 power. It's actually just, we call it f inverse. I do want you to note that this is not the same as 1 over f of x. We actually write that as, we write the -1 on the outside if we have something like that. So just keep that in mind. So basically what an inverse function is, it's a function that undoes another function. And you can find your inverse functions by switching all elements of the domain and range. Or you can think of it as just switching the x and y's. So, I just wrote this out. Basically, the x and the y values get switched. So let's do a few examples. And before I do an example, actually, I do want to mention, to find an inverse, you have to have your original function must be 1 to 1. Otherwise, it doesn't have an inverse. So hopefully you remember what 1 to 1 is from the previous video. If you haven't watched the 1 to 1 video, I'd recommend you go back and watch that one first. So let's do some examples. We are going to be finding our inverse function. And my first example, I'm actually going to give you a set of ordered pairs. So first thing I'm going to double check is making sure that every x has only one y and every y has only one x. That is the case here. There are no x's repeated and there are no y's repeated, so I'm good there. For my inverse, all I need to do for this one is actually just switch around the x and the y values. So -2, 4 changes to 4, -2. 3, 2 changes to 2, 3. 0, 8, -8 changes to -8, 0. And 1, 5 changes to 5, 1. And you're going to find that when we have an equation, you do a similar thing. You're going to switch your x and y values. For number 2, we are also finding the inverse. And my first step whenever I have something like this is I think it's a lot easier to work with a y than it is with an f of x. So I start by rewriting f as a y. And actually, occasionally you'll get variables that are not x's and y's or that are not f's and y's. In that case, I probably would still rewrite them as x and y. I think it makes the problem a lot easier to deal with. So that's my first step. The second step is the actual taking the inverse step. And in the next step, we are going to switch around my x and my y. So we are going to switch those around. The next thing we're going to do is we are going to solve for y. Give you a nice cube here. You're welcome to try that on your own. I'm going to move over my 6. And once I move over my 6, I need to divide by 3. So I get x plus 6 over 3 is equal to y cubed. Then I end up getting that y equals the cube root of x plus 6 over 3. Not the nicest function, but that's all I need to do. I don't need to simplify it. So now I rewrite my y with as f inverse. So I just end up with this in the end. We have an important rule with functions, and that's that if two functions are inverses, when you find the composite function of both of those in either direction, either f of g of x or g of f of x, you will get x. So a popular question that you often will see is to verify that two functions are inverses. So let's do one of those. For this example, we're verifying that these two functions are inverses. So we're just going to go ahead, first of all, find f of g of x And so when I do that, I get f of 4 over x plus 3, which I'm going to substitute in to that denominator. So I get 4 over x plus 3 like that. So, and then the other thing I have is I have a minus 3. So this goes in for my x, and then I keep my minus 3 the same. So once I do that, I can simplify it out. The 3 and the negative 3, the 3 and the minus 3 are going to cancel out. So I get 4 over 4x. In order to simplify this, I'm going to multiply this whole entire fraction by x over x. The reason I'm going to do that is because my numerator I get 4x, my denominator, my two x's cancel out, so I get 4x over 4, or x. So I'm off to a really good start. I found that the first thing was f of g of x is equal to x. I need to now do the same for g of f of x. So I'm going to do g of 4 over x minus 3. And I end up getting 4 over that whole thing, 4 over x minus 3. I get these complicated fractions here, plus 3. In order to simplify that thing out, I'm going to multiply both the numerator and the denominator by x minus 3. So that's equivalent to multiplying by x minus 3 over x minus 3. Just that, since the numerator and denominator there are equal, it would be the same as multiplying by 1. You're always allowed to do that in math. So my numerator now is going to become 4 over x minus 3. In my denominator, these x minus 3's cancel out, so I get that over 4. I then have that is plus 3. You can see that the 4's cancel out, which gives me x minus 3 plus 3, and that also gives me x. So I'm good on that one. So I've verified that. You can write a sentence if you want. You can say f of g of x and g equals g of f of x equals x, so f and g are inverses. That's a nice thing to do. But you don't have to. If you get all of these and show that they're x, you're doing well. So for this example, we're going to draw a graph of an inverse function. So this blue one is my function f, and I would like to draw the inverse of f. There's really two ways that you could think about it. The first thing that you can do is you can think about it as you're switching the x and the y values. And the second thing you can think about is that you are reflecting over the line y equals x. So I'm actually going to start by drawing y equals x. I think that's the best way to get started. So this yellow one is y equals x. So you can just think that if we were to take this blue function and flip it over that line, that would give us the inverse. Now, some people are not very good at like being able to visualize that. So the other way that you can do it is you can switch the x and the y values and just plot points, and then maybe use the y equals x line to help you get the right shape. That's usually the way that I do it. So I'm going to start, this point is -2, -3. The point that corresponds to that on my other graph is going to be -3, -2. So that's the point on the inverse that corresponds to that. I have a point at -1, 0. My inverse has a corresponding point at 0, -1. And if you look at this carefully, you can kind of see that if I try to connect those things, in fact, I'm going to find my intermediate point is about at -2, -2. So I will go through that on my inverse, because if I switch around -2 and -2, I just get -2. But it is kind of at a curve. So that's the first part of my graph. Another one that we see is that we have 0, 1, which means that my inverse has 1, 0. So I'm going to have a point right there. I can draw that there. The regular function has 3, 2. That means that my inverse has the point 2, 3. So again, I can keep on trying to draw it using that. And then the last one, it looks like I have a point about 5, 4-ish. So I'm going to draw one at 4, 5. I don't have 5 on this graph, but you can kind of take a guess. And then it's going to go along like that. So it's not a perfect graph. You don't have to be perfect, but you kind of get the idea. I'm hoping. So I just want you to basically get the right idea of what it looks like. So I want you to notice that the x and the y values switch around, and it's also a reflection over the line y equals x.